Hello and good evening. In this project, we are using the dataset, which was collected from Kaggle website. This dataset is about the weather in Boston state. The main aim of this project is to predict the weather over next 5 years with the data collected. It is the dataset of 24 attributes along with the 3,749 observations. It contains the important variables such as year, day, date, and average temperature that plays a major role in forecasting. The weather directly depends on humidity, visibility, wind, snow, and rain. Let's move on to the next topic, data preparation. The Boston climate is generated based on the daily basis. In order to get the data corresponding to the season, important attributes are grouped. When grouping by, the average temperature of a month is obtained by taking the mean of daily temperature values of the particular month as clearly shown in the table. While investigating, there are neither null values nor the missing values in it. Time series plot is shown here. We can observe the absence of seasonality, change in variance, and intervention. There is an obvious trend and auto-regression in this. When the scatter plot is plotted, it can be noticed that there is an upward trend that tells us that the data is not stationary. There is a correlation between them where the value is around 0.76. It can be clearly said that there is a strong dependencies between them. Following with is the fitting the model. The first model is linear model. When plotted the linear model, the line fails to capture multiple points even though the p-value is less than 0.05. Then we decided to test quadratic model as well. When performed, we received as same results as linear model. That is, it did not capture more points. In order to fit the best model, residual analysis is performed. Linear model is labeled as model 1 and quadratic model is labeled as model 2 respectively. The QQ plot in model 1 shows that very few points are away from the red line and leaving p-value as 0.01, that is less than 0.05. The QQ plot in model 2 displays in that there are more points that are not on the red line. Shapiro-Wilk test shows that the p-value as 0.0041, that is still less than 0.05. That is almost similar to each other, and we can reject the null hypothesis, which says that the data is normally distributed. Next, we are checking the stationary of the data. ACF plot shows that there is a little trend in it, while PCF shows there is one significant value, which can be said that there is non-stationary in data. The data is transformed using the lambda value as 0.8. Then the Dickey-Fuller test is performed on it, where the result shows p-value as 0.01. It is less than 0.05, but when we observe the graph, it represents the trend. When the trend exits, it is said that the data is non-stationary. In order to convert the data into stationary, differencing is used on the transformed data. After the first differencing, the trend has vanished. Again, we check for ACF and PSCF. It represents one significant lags on each one of them. To be more accurate, we used ESCF and BIC tables as well. ARIMA, P, D, and Q, where P represents AR, Q represents MA, and D represents the level of differencing. According to BIC table, test means AR, error means MA. The second test lag captures most of the models, and the fourth error lag captures most of the models. So we can say it as AR2 and MA4. In EACF, we can see that it is 02, 03, and 13. So ARIMA of 012, ARIMA 013, ARIMA 113, and ARIMA 214 were the models here. We evaluated according to AIC and BIC scores in order to choose the best model, where ARIMA 013 was considered the best in it. The first graph here shows that it is around the mean value. Histogram shows that the data looks symmetric. It has a bell shape in it. There are no significant and patterns in EACF and PACF respectively. The model also looks normalized as all the points are on the line. Zoom box test shows that all points are located above the red line. To sum up, the model gives ARIMA 013, which works well with the Boston weather. Last, forecasting. The data here is first de-transformed and then forecast. From forecasting, we observe that there is a slight rise in temperature over the next few years. Thank you.